See, Zara, from the first chapter, few things, a basic dimensional formula you should be able to write, I think. Now, the difficult questions, or more than difficult questions, the application based questions. Those, let me tell you. So, this says that check the correctness of the relation torque is equal to I into alpha. Okay, where torque is tau is the torque acting on the body and I is the moment of inertia. Okay, rotational motion has not been discussed, no, in your school. Rotational motion has not been started, right? So I'll tell you the formula here.
Ma'am, your
Okay.
voice is breaking a lot.
My voice. Okay, wait. Zara, now is it better? Is my voice better?
Yes, ma'am, it is.
Okay. See, I was saying that the basic formula from the writing of the dimensional formula that you will be able to write. The kind of questions based on the applications that I'll do, just few questions from every chapter so that a little bit is covered. First is checking the correctness of any relation, or the same question can be given in the form. The torque is depending on moment of inertia. Same question, this can be written as torque depends on the moment of inertia and alpha, calculate the dimensions. Both the kinds of questions are possible. Now, since you don't know anything about rotational motion, I'll just give you the formula here because your purpose is to write down the final formula. You don't have to remember these formula right now. Torque is basically radius multiplied to the force, and moment of inertia is mass multiplied to radius square. So your task will be to see when it says check the correctness of the relation. Don't write anything. I'll give you time to copy everything. When it says check the relation of both the sides, you'll have to calculate this side as well as this side. Or you can simply say, see, torque is this R into F, I is equal to mr square. Okay. And alpha, okay, one more thing. Alpha also we have not written. See, alpha is the angular velocity divided by time. All these things are present. Now, so now we just have to write the dimensions and match. Are they matching or not? So left hand side, let's say we have torque, and torque is radius into force. Now radius dimension is length L, and forces dimension is mlt to the power minus 2. So in short, we get ml square t to the power minus 2. Now let's come to the RHS, that is I into alpha. This is I multiplied to alpha. Now I formula of moment of inertia is mr square. Mr square means mass into length square, L square, which is equal to ml square. Coming to alpha, alpha is equal to omega by t. Now omega is already t to the power minus 1. So alpha is t to the power minus 2. So see, when we put in all the things, RHS, I is ml square into t to the power minus 2. That is equal to ml square t to the power minus. Look, LHS and both RHS are same. So we say the formula is consistent. Consistent in the sense that yes, this formula tau is equal to I alpha. This is correct. So likewise, you can get any formula whose relation you have to write. Okay, this dependency when I'll tell you separately. Don't add it here. This I'll tell you one more question. This question is clear?
Yes, ma'am, it is.
Okay, quickly write it. One more question I'll discuss.
Ma'am, I have a few questions. If possible, can I get help in those?
Yeah, share them. Share it on WhatsApp.
Yep. Okay, I will. Ma'am, can you scroll this down? Finish writing, ma'am.
Yes, Zara, have you shared those questions?
Yes, I've shared the questions on WhatsApp, ma'am, with the team.
Okay. Or if you want, you can, I think photos are uploaded on the chat box also, no?
This chat box?
The chat box of the Zoom.
The chat is disabled.
Chat is disabled.
Yes, it is.
Wait. Now see?
Yes, I have just sent it. Ma'am, I've shared the first question.
What? Zara?
I have shared the first question in the chat box.
Not visible.
It is to
Has it been
Learnivio, ma'am. It is personally sent to Learnivio.
No, no, don't share to them. That's the host.
Oh, wait one sec. Done, ma'am.
Okay. This one, establish relation between centripetal acceleration
And angular speed.
and angular speed. Uh, yes. This question, okay, from projectile also is coming, no? That's why this
Yeah.
must have been given.
This was there for 3
See,
marks.
yeah, centripetal acceleration and angular speed is A is equal to omega square r. Okay, I'll tell you here now. I think I have it. Wait. Yeah. Look, Zara, here centripetal acceleration and angular speed, no? Yeah.
Hmm.
Okay. See, this derivation is already written, so it will help you just understand. Okay, I'll give you this understanding, then you can copy it later. What has happened is, so this is a portion of the circular motion. So a circle is there, and from here, point O is taken to this point. Let's say there is some point B, and to this point, that is some point R. It is the circle is intersecting with the radius at this point A and at this point B. Okay, this is your A point and this is the B point. And the angle of subtension is theta, some theta, we don't know. Okay, so this will be the radius of the circle, this will be the radius because this is exactly at the center of the circle. Now, remember, whenever you have velocities, these are actually the linear velocities. And when we talk about the linear velocities are tangent to the circle. They are tangent through the circle, means tangential to the circle. So if this is a point, tangent is like this. If this is B point, the tangent is like this. Any point wherever I take, let's say there's a point here. So this is how I'll take. And if there's a point here, this is how I'll take. Means linear velocity's direction in a circular motion is always given by a tangent. While the angular velocity, this is the angular speed, this is the axial. Okay, this is axial. When I say axial, it means this acts at the axis. Like imagine a fan is there. Fan is rotating. There's the central axis of the fan. That axis of the fan, when we are talking about that axis of the fan, the entire fan is moving. So that's a rotation motion. But since the rotation part, the actual rotation part that is occurring is because of that axis, the main axis that holds the fan. So that axis is basically undergoing the angular speed. Angular speed, this is getting rotated because of which the other fan blades are moving beside it. So that's why we say this is an axial vector. That is, its direction is always axial. But when we talk about the linear speed, V is your linear velocity. Linear velocity acts always tangentially. This acts as a tangent. So here one tangent has been taken for this A point, that is VA. Another tangent has been taken for this B point, that is VB. Okay. And see one more thing. These lines are extended, and this is also theta by geometry. This angle is also theta. This angle is taken theta. the angle between the tangents here, the exterior angle will be equal to this angle. Because of the entire geometry, this angle, they are equal. So this means you don't have to go into the details, so I'll just tell you in short. See, this angle will be equal to x plus x. So you get 2x plus theta is 180. Theta is equal to 180 minus 2x. Similarly, here you get 180 minus theta. So theta is equal to this angle. So this angle and this angle is equal. Again, I'm saying you don't have to go into the details because by geometry they are already equal and they're assumed to be equal. But you should remember that this is also theta. So what we do, we draw this separately. This is VA, this is VB, this is theta between them. Same thing that has been drawn separately. Now, this part is there. When we use the triangle law, when vector is acting like this, okay, another vector is acting like this. Or when we use the parallelogram law, basically the resultant is pointing here. Or you can say this is the closing side of the triangle. So this shows that this is their final difference. Their final resultant VB minus VA is given from the closing end. And all these are just drawn by construction. Means this side, one side is VA, another side is VB, and the closing side is VB minus VA. As in they are vectors, velocities are vectors, and vectorically when you solve them, this is how you represent according to the vector laws. So this is how these diagrams are put. And one more thing, there is one length. This part, this circumferential part, this is known as the length of the circle. This part, this is the length of the circle. While this is the displacement, so that has been marked as delta S, the displacement. Now see, first tell me the diagrams are clear, these two diagrams.
Yes, they are clear, ma'am.
Okay. Now see Zara, once the diagrams are clear, no, calculation is very, very, very easy. You'll find them very easy. See how? This triangle is there, this part is pushed there, and this extra part I have drawn already separately. So come look at this one and look at this inner triangle. Now calculations are very simple. The formula of any angle, whenever you have any angle, the angle basically says the length of the arc divided by the radius of the arc. This is the formula for the angle, length of the arc by the radius of the arc. So theta is equal to L by R. L means whatever is the length, this curved length. But see, the curved length and this S, delta S, they are very, very, very close to each other. So you can almost say this L is almost equal to this delta S, means the separation between A and B points. What is delta S? I'll just mention it here. Delta S is the separation between A and B. So we can say theta is equal to delta S by R. Theta is L by R. L is almost equal to delta S. So theta is equal to delta S by R. Do you agree?
Yes.
Okay. Similarly, on the opposite side, if we take the same logic here, theta, so this change is delta V. Here the change that we are getting is delta V. So this time it will be delta V by V. Whatever is the velocity, delta V by V. Right? This will be delta V by V because the length is of the velocity itself. Correct? So delta V by V is theta and the theta is delta S by S. So can we equate this with this because both of them are giving you the same angle theta? Can we?
Yes, we can.
So see, delta S by R is equal to delta V by V. Now you cross multiply them, you will get delta S into V is equal to delta V into R, just cross multiplication. Now see, from here, what do? We look, delta S into V is equal to delta V into R. This much we have got. We differentiate this term. I'll tell you this here. Hello, Mama. Mama. The equation that we have over here is delta S into V is equal to delta V into R. This is the equation. See, if you differentiate it with respect to time, if I differentiate it differentiate with respect to time, I'll get ds over dt into v is equal to dv over dt into r. That's what we discussed yesterday. Remember? ds over dt, dv over
Yes, ma'am.
dt.
Remember.
So look, ds over dt is nothing but your velocity. Rate of change of displacement is what? This is velocity. And rate of change of velocity is acceleration. dv over dt is acceleration. So what do we get? We get ds over dt can be written as v. One v is already present. dv over dt can be written as a into r. From here, we can say centripetal acceleration is v square divided by r. Now we have to introduce angular speed. See, angular speed, linear velocity, and radius, they are connected. V is equal to omega r. So, v square is equal to omega square r square. So, when we put this value over here, centripetal acceleration will be omega square r square divided by r. One radius will cancel this. Centripetal acceleration is equal to omega square r. Relationship established. Entire derivation. Clear?
Yes.
Okay. Write it down, Sarah.
Working for 3 marks.
What?
I'll have to do the whole thing for 3 marks.
Yes, yes. It's a 3 marker question. Yes.
Yeah. Ma'am, I'll just take the pictures for this. I don't want to waste time in writing this today.
Oh, all right. Do you have more questions?
Yes, I have a few more. That's why.
Okay, okay. You can take the
Ma'am, can you
screenshot.
scroll down? I took the screenshot. Done, ma'am. Yes, ma'am, done.
Okay, share the next.
Hmm. Ma'am, I'll send it on the chat. This is for velocity. Find the resultant velocity.
Okay, this is a motorboat is racing towards the north with 15 km per hour, and water is in the region 5 km per hour in the direction 60 degree east of south. Okay, you have to find the resultant velocity of the boat. So this is a question based on relative velocity. See, very easy. This question I'll just explain you here. Velocities are given. Now, one thing you should know, what is the angle present between them? Let me just open your question as well. Okay.
60
So
degrees,
this
right?
is 60 degree east of south. So we have to locate this first because we have to find out an angle. This is north, south, east, west. So 60 degree east of south means from south it is 60 degree. This is one point. This is your one of the velocities. Okay. That is 5 km per hour. It is saying no 5 km in the direction 60 degree. So 5 km per hour is like this. And there is another vector whose value was given 15 towards the north, right? Is
Yes.
racing at the north like this. So north means directly north like this. That is simply 15.
15 km per hour.
Yes, 15 km per hour like this. Now see two vectors. They are representing the adjacent sides of the parallelogram. Okay. When they are representing the adjacent sides of the parallelogram, what did we discuss parallelogram any day? Or we just
No,
started, we didn't. See, whenever two sides are there representing the adjacent sides of parallelogram, then we apply a parallelogram law. Parallelogram law's magnitude is given by, see, few things are there, a brief discussion.
I know this, ma'am. You can
You
just solve
know
it.
the parallelogram law properly?
Yes, yes, I know. If two
I'll
vector,
move you
sorry,
this.
the
Okay. So see,
parallelogram, right? I
yes.
have it.
So this is your one vector, let's say v1. This is your another vector v2. Their resultant will be lying somewhere here between them, means when you complete the parallelogram, like this. Here the resultant will be lying VR or wherever. You just have to complete the parallelogram and check where will the resultant be lying. Okay. Next thing is angle between both of these. So angle with 60 degrees given outside. So in between, the angle will be 120 degrees. See, complete is
Yes.
180, 60 from here. So angle is, so your one vector, you are just going to use R is equal to under root V1 square plus V2 square plus 2 V1 V2 cos theta. Your V1 is 5, V2 is 15, and theta is cos 120 degree. That is minus half. Put the values, R value magnitude you will get. Got it?
Yes.
Take the screenshot. Share the next question.
Done, ma'am. So I'll have to make the figure to know if I'll have to use the parallelogram law.
Have to draw the figures. That's why it shows no, they are co-initial. Until they are co-initial, you can't use the parallelogram.
Hmm. Okay. Shared, ma'am. Ma'am, also I have this doubt. Whenever they say that it is south north, can I assume that it's the parallelogram law?
Usually it's the parallelogram, but triangle law can also be used. No? If I say, in the similar question, if I say, a man travels, let's say 5 kilometers towards east, one velocity will be this, and then he travels 15 kilometers towards the north. So this is not parallelogram. This is the triangle law. So you'll have to draw the figures. Got it?
Okay.
Okay. I think you have shared something, no?
Yes, yes.
Establish V is equal to U plus 80, S is equal to UT plus half 80. Here only let me explain. Or I think I might have this written. Wait. I must have this. Actually, you didn't attend the earlier classes, no, with me. That's why these things are not done. Otherwise, these were in the completed in the classes. No
Thing
problem.
is, ma'am, they told me I can skip the exam. They did not inform me about the exam until last week. They did not tell me. I think they told me on Thursday.
They told you on Thursday. Okay.
Because they said that because I was not available for the exams and I wrote it for 12th grade, so they'll skip it. But then all of a sudden they thought that it would be better if I could pass the exams.
Okay, that's fine. No problem. Let's see. Just focus on passing the exams only then.
Yes, yes.
See, Zara. First, for the first equation, start with A is equal to dv over dt. Okay. Now, as I told you yesterday, I told you whenever you have velocity, whenever the smaller terms are asked, and you want to expand it from some value to another value, you go for integration. Means you do the opposite. If this is given, you go for differentiation. You just do the opposite, like the way we do it for multiplication, division, addition, and subtraction. So if I want to get velocity from this equation, I'll get dv is equal to a dt. Yeah.
Yes. Yes.
So see, velocity, I am here differentiating velocity. So when I'm differentiating velocity, I'll have to put the limits of velocity to. Initial velocity is u, final velocity is v.
Me.
Yes. And similarly, in here you have to see which variable are you integrating. Are you integrating acceleration? Is it dA? No. You are integrating time. You are expanding time. So limits also from 0 to some value t. Now, integral, remember, integral of dv is v only. The integral of dv is v velocity. So you put the limit as v from u to v. Now, acceleration is the constant term. We discussed yesterday that acceleration comes out of it. So integral dt from 0 to t. Now, put the upper limit. V minus u is equal to a t minus 0. So that gives v minus u is equal to at. Shifted here, v is equal to u plus at. Clear?
Yes.
Now for displacement, what we do for the second equation, v is equal to ds over dt. We know this. And if I want to write the equation of displacement, I'll write it again v dt. ds is equal to v dt like this. Now
Oh,
use this relation that you have got. I'll show you. See, v dt is equal to ds. Now using v is equal to u plus at from the equation 1 that we already have. If you put it here, you will get this. Now multiply dt inside so that you can separate the terms. You can segregate all these terms, just separate them. So ds is equal to integration from 0 to t. This can be written as u dt integration from 0 to t and at dt integration from 0 to t. Basically, I have multiplied it and separated it so that the integration is a little clear and visible to us. Okay. Now see, s integral of ds will give us s from 0 to s. So s minus 0 will give us the displacement s. Similarly, u is the constant term, so u comes out. If u comes out, we are left with integral of dt that is equal to t only. So we integrate it from 0 to t. So t minus 0 is t only. So we get ut from this side. Acceleration is constant. Now integral of t to the power 1 plus 1 divided by 1 plus 1. That's what we did. So t square divided by 2 from 0 to t. So here when you put the values, a by 2, t square minus 0 square, this is equal to s is equal to ut plus half at square, where these are the meanings. Fine.
yes.
Okay, I'll just check my video so that you can take the screenshots.
Okay. Ma'am, can you scroll up to the beginning? I'll start taking pictures from there.
This is
Done,
it.
ma'am. Done. A little up, ma'am, because I did not take the second part. Done, ma'am. Done. Done, ma'am. I'm done with everything.
Okay, Zara. So the next.
Can I read it out instead of typing it down?
Read it.
It's a numerical. Forces of 16N and 12N are acting on a mass of 200 kgs in mutually perpendicular directions. Find the magnitude of the acceleration produced.
Wait, Zara. I have to write down things.
Okay.
Please dictate it again.
Okay. Forces of 16N and 12N are acting on a mass of 200
Wait.
kgs
Force of 16 Newton. Second force
and
given is
12 Newton.
12 Newton. They are acting on a mass of
200 kgs in perpendicular direction, mutually perpendicular direction.
okay. Theta is 90 degree. Fine.
Yes. Find the magnitude of the acceleration produced.
See,
We'll use
so
F to MA, right?
we'll use MA. F is equal to MA. Very easy question. Look, F net is equal to mass into acceleration. Acceleration will be the net force divided by mass. Now, when two vectors are perpendicular to each other, so we can say under root f1 square plus f2 square only, because plus 2f1 f2 cos 90 degree, cos 90 degree is 0. So this way, this will also be 0.
Yes.
So only this part will be left. So my net force, which is the resultant, will be under root of 16 square plus 12 square, that is equal to 20 Newton. The resultant of these will be 20 Newton. So acceleration is net force by mass, that is 20 by 200, so 0.1 meter per second.
Why did we take root?
Root because two vectors are perpendicular to each other. This is F1, this is F2. They are making an angle of 90 degree. Apply the parallelogram law. Under root a square plus b square plus 2ab cos theta. The 2ab cos theta part is 0 here, no? F1 square plus F2 square plus 2 F1 F2 cos 90 degree. This whole will be 0 because cos 90 is 0. So you'll be left with under root F1 square plus F2 square.
Okay.
Got it properly?
Yes.
Take the screenshot of this one as well.
Done, ma'am. I took the screenshot.
Okay. Next.
In which of the following situations is no work being done by the object exerting the force?
Work done. Work done is given to you.
The question is, in which of the following situations is no work being done by the object exerting the force?
Now that is fine, but this is a question from work, energy, and power. Okay,
But we
anyways.
only have 4 chapters for this, ma'am. I don't know why it's there.
This we have already discussed the when the work done will be due. Anyways, you dictate, you say the question.
A person is applying a normal force to a box to push it along a horizontal surface at a constant speed.
Okay. Other options are also there.
Yes, a person is holding a string that is exerting a force on a ball attached to the other end. The ball is moving in a circular path.
Okay, next.
That's it. It's like a 2 mark question.
Okay. See, Zara, this you should be able to answer. This we have already discussed. The conditions when the work done will be 0. I told you two possibilities are there for work done to be 0. If the applied force is perpendicular to displacement, then because you have F dot S, that is Fs cos 90 degree and cos 90 degree is 0. Second condition is if there is no displacement produced or no force acting, then work done is 0. So I think the answer is in front of you. Force is perpendicular to the displacement.
B.
Got it?
Yes.
So, but this is a question from work energy and power. I don't know. Anyways, anything else, Zara?
That's why I was asking you this question because I'm confused if it's there from the first 4 chapters or not because
No, no,
I
no. This is there from work energy and power. I think they must have a different syllabus that time. No,
No,
but work
I
energy and
was
power has
specifically
started.
asking her because we started this week. I was like, is it there? She's like, no, it's not there.
Okay, then maybe this question she must have discussed in the class or something. Because see, clearly work done, as soon as the term work done comes from your chapter 5 only. There is no mention of work done before that. So this is actually a question of chapter 5 itself. But anyways, it's okay if we have discussed. I don't think
Done with the questions, ma'am.
you're done. So anything else?
No, ma'am,
What
nothing
you can
else.
do, Zara, if you need any help with other questions also, you can share it on WhatsApp also to the Learnivio team. They'll forward it to me, and I can provide you the video solution or anything you want. Okay, that can also be done.
You're ma'am.
Okay, so I hope these queries are clear. Today's class.
Yes.